Welcome to Skill Practice Guided Notes. Today we'll be going over gases and moles, which is Skill Practice 36. First question. In this question, you are asked to solve for the number of moles of gas in a scuba tank. You are given the temperature, the pressure, and the volume. To solve for number of moles, you will simply use PV equals nRT. Before you can plug in pressure and temperature into the equation, you will have to convert pressure into atm and temperature into Kelvin. Once you do so, you can plug in the numbers and you will be left with the number of moles. For this question, the conditions have changed, but the process hasn't. Instead of solving for number of moles, you will solve for volume and PV equals nRT. Again, before you could plug in pressure and temperature, you had to convert pressure to atm and temperature to Kelvin. Now in this question, you're not asked to solve for number of moles or volume, you're asked to solve for the ideal gas constant R, which in most cases is 0.0821, which is the ideal gas constant for the Earth, but not for the planet X. To solve for the ideal gas constant for the planet X, you will simply use PV equals nRT again, and plug in the pressure, the volume, the number of moles, and the temperature. You got to make sure that the temperature is in Kelvin, but in this case, you don't have to worry about the pressure being in kilopascals. Question 4. In this question, you are asked to solve for the molar mass of the given gas, and name the gas. You are given the pressure, the temperature, the volume, and this time you're also given the mass of the gas. First, you will use the PV equals nRT equation and solve for number of moles. Once you get that, you will divide the mass by number of moles to give you grams per mole, which is the molar mass. In this case, we got 40.04 grams per mole, which is the closest to the molar mass of argon. Question 5. In this question, you are told that the gas given is oxygen. You're also given the volume, the pressure, and the temperature. What you're asked to solve is the mass of the gas. But before you could do that, you had to solve for the number of moles. So you use PV equals nRT and solve for number of moles of the oxygen. Then you use the molar mass of oxygen, which is 32 grams per mole, and multiply that by the number of moles to give you grams of O2. In this question, you're given the volume in milliliters, temperature in degrees Celsius, and pressure in kilopascals. And you are asked to solve for number of moles. Before you can solve for number of moles, make sure you convert milliliters to liters, degrees Celsius to Kelvin, and kilopascals to atm, so the units can cancel out and give you unit moles. Last question. Now this time, you're going to use a different equation. It's just a different version of PV equals nRT. The actual equation is P1V1 over T1N1 equals P2V2 over T2N2. But in this case, since the number of moles is constant, it's not going to affect the answer. So that's why you could cancel those out and use pressure, volume, and temperature to figure out the second volume. For pressure 1, volume 1, and temperature 1, you're going to use the ideal conditions, which are 1 atm, 22.4 liters, and 298 Kelvin, which is 25 degrees Celsius, the room temperature. You're given the pressure 2, which is 135 kilopascals, which you're going to need to convert into atm, and you're given the temperature, which is 45 degrees Celsius, which again, you're going to have to convert into Kelvin. Now you will simply plug in all the numbers into the equation and solve for V2, which in this case is 17.9 liters.